Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okey, dalam video kali ini kita akan discuss berkenaan dengan chapter 7 okey, dalam kursus power quality, which is voltage irregularities. Okey, part 1. Okay, this is outline of this chapter. Okay, first of all, we'll discuss about introduction, what is power quality. Next, we will discuss about power quality problems that related to the voltage, and then we'll discuss about standard. Okay, for learning outcomes, okay, after you completing this chapter, actually you should be able to, number one, explain the power quality problem related to the voltage waveform. Number 2, describe the impact of transients to the network and equipment. Number 3, suggest the suitable protection equipments to prevent transients over voltage. Okay, for the introduction, power quality. What is the meaning of power quality problem? What do you understand with the power quality problem? Basically, power quality problem actually is any deviation of voltage, deviation of the voltage, currents, and frequency at the load side, deviation from the standard voltage waveform, currents, and frequency. Okay, this is the introduction, brief introduction about power quality problem. Then what is the meaning of good power quality? Okay, what is the meaning of the good power quality? Okay, good power quality basically is the voltage should be within the acceptable limit, permissible limit. Okay, for example, in Malaysia, at the distribution level, at the load side, especially for the residential, for example, our voltage limit actually is plus 10 minus 6% from the nominal value, from the 230 degree, okay, for a single phase system. Okay, number 2, the shape of the waveform should be pure sine wave, okay, pure sinusoidal waveform, okay. There is no distortion, there is no harmonic, and so on. Okay. Number 3, all the three phases voltage should be same or should be symmetrical. Okay. This is the example of the normal voltage. You can see from the figure. Okay, the first part of the waveform we call it normal voltage. Okay, pure sinusoidal waveform. Okay, you can see from this from the first part of the figure. This is the normal voltage, and then we can have EMI or RFI effect to the normal voltage, or maybe we can have a spike or impulse transient. Okay, we have a spike, okay, whether at the negative waveform, negative side, or positive side of the waveform. We have a transient, okay, transient, oscillatory transient. Okay, we have the transient, okay, oscillate at very high frequency. Maybe we can have a harmonics, okay, harmonic due to the nonlinear loop. Okay, sometimes we can have in some cases we have a surge, okay, surge from the, for example, from the lightning, okay, from the lightning strike. Okay, we have a surge. Of course, we have a over voltage, okay, over voltage. Maybe in some cases we have a sag or under voltage, or we have a power failure. Power failure, there is no supply, voltage equal to 0. Okay, this is the Malaysia electricity supply. Okay, this is the steady state voltage regulation limit under normal condition. Okay, this is for Malaysia. Okay, for example, we have a voltage level. Sekiranya kita ada voltage level 400 volt and 230 volt. Yang ni adalah pada distribution level, okay, ataupun kat rumah kita. Kat rumah kita ada 3 phase. Sekiranya dekat rumah kita guna 3 phase, if we use 3 phase, we have a 400 volt 3 phase line to line voltage. For the single phase line to the neutral voltage, we have a 230 volt. This is the acceptable limits of the voltage. Okay, minus 6% and plus 10%. Okay, let's say we have different types of voltage level. Maybe for the industrial sector, let's say we have a 6.6, 11 kV, 22 or 33 kV, this is the limits, plus minus 5%. Okay, if we go beyond than 33 kV, for example, we have 132 kV, 275 kV, this is the limit, okay, plus minus 5%. Okay, similarly to 500 kV, okay, plus minus 5%. How about frequency? What is the limit of frequency? What is the acceptable limit for the frequency? Okay, in Malaysia, our frequency actually is 50 Hz. Okay, 50 Hz with plus minus 1%, which is plus 1% from the 50 Hz or minus 1% from the 50 Hz. Okay, first voltage, number 2 frequency, and number 3 actually is power factor. Okay, power factor, consumer are required to maintain the load power factor to minimum of 0.85. Okay, 0.85. Okay, for the voltage level less than 132. Okay, less than 132 kV. If our intake or our main supply actually is less than 132, we should maintain our power factor actually is minimum or higher than 0.85. If you have a power factor less than 0.5, of course you will be penalized. Okay, you will be charged by the utility. Okay, or 0.9. Okay, if your voltage level is 132 kV and above, you should maintain your power factor 0.9 and above. Okay, 0.9 until 1. Okay, if you have a power factor below than 0.9, so you will be penalized by utility or by TNB. Okay, power quality problem. Okay, the problems due to the poor power quality includes, number 1, it can be from low voltage than nominal voltage in the system, low voltage, or high voltage, okay, then nominal voltage. Okay, what is the nominal voltage? This is the nominal voltage. Okay, depend to the application. Okay, flicker, we have a voltage flicker, we have a harmonic in the distribution system. Harmonic basically come from the nonlinear load. Okay, we have a lower power factor, okay, lower than this acceptable value of the power factor, or we have a voltage transient, maybe due to the lightning and so on. Okay, first of all, we discuss about voltage sag. What is voltage sag? Okay, look at to this figure. Let's say this is a normal voltage. This is a normal voltage. Okay, for few cycle we have a normal voltage. Let's say kita ada 1 per unit, 1 per unit. This is a 1 per unit magnitude of the normal voltage. Okay, voltage sag or dip basically is represent a voltage fall. Okay, voltage fall to 0.1 to 0.9 per unit. Okay, 0.1, for example, let's say we have a voltage fall to 0.5, for example. Okay, 0.5 per unit for less than 1 minute. Okay, if less than 1 minute, that one we call it a voltage sag. Okay, or voltage dip. Okay, voltage sag can cause loss of production in automated process since a voltage sag trip a motor or cause its controller to malfunction. Okay, this controller from the microprocessor based controller, programmable logic controller, or adjustable speed drive for the motor. Okay, that may lead to a process stop. Okay, stop. Okay, tripping a contactors and loss of efficiency of electric machine. This is a voltage sag. Okay, fall to the 0.1 to 0.9. Okay, this one we call it a voltage sag. Okay, number 2, we have a voltage swell. Okay, this is the problem. This is the power quality problem that related to the voltage swell. Okay, voltage swell, what is the meaning of voltage swell? Voltage swell is the rise in voltage. Okay, rise in voltage. Let's say this is a normal voltage. Look at this figure. We have a normal voltage. Okay, at certain period, okay, that voltage will be rise greater than, let's say, greater than 1.1 per unit. Okay, let's say this is a normal voltage, 1 per unit of magnitude, and then this voltage suddenly increase beyond or greater than 1.1 per unit and exists, okay, for less than 1 minute. Okay, less than 1 minute. is maintained less than 1 minute, so that one we call it a voltage swell or voltage rise. Okay, this voltage swell usually associated with the system fault condition, okay, due to the fault, but they are much less than voltage set. Okay, commonly they are less common than voltage set. Okay, normally we have a problem with voltage set. Okay, voltage swell can also be caused by switching off. Okay, sometimes we suddenly off our load, especially our large load, or switching on a large capacitor bank. Okay, when we have a switch off of the large load or switch on a large capacitor bank, we have a situation voltage suddenly increase. Okay, suddenly increase greater than a nominal value. Okay, voltage swell can put stress on. What is the effect of voltage stress? Okay, voltage stress can put stress on computer, electronic devices, and many home appliances. Okay, and many home appliances. Okay, it can put stress on the computer and home appliances. It also cause a tripping of protection circuit of an adjustable speed drive. Okay, because this voltage is suddenly increased, maybe beyond the setting and so on. Okay, flicker. Okay, this flicker actually is due to the switching on and off of loads on a weak distribution system. Voltage flicker occur. Okay, voltage variation occur. This voltage flicker actually is voltage variation occur due to small short circuit capacity in the distribution system. Okay, what is the effect? It's a result of rapid variation in voltage. Rapid variation, you can see from this figure, we have a rapid variation due to the fast changes in load. This one we call it a flicker. Okay, this caused by large motor decrease in voltage. This decrease in voltage cause voltage flicker on other loads which are connected to the same distribution system. Okay, same bus bar, for example. Okay, this voltage flickers actually is very dangerous to sensitive load. Okay, changing, okay, rapid variation in voltage, of course it can damage the sensitive load. Okay, next we have a harmonic. Okay, we already discussed about harmony in the previous chapter. Okay, what is the meaning of harmonic? Okay, this is the example of the harmonic waveform. We have a voltage waveform, for example. Okay, this waveform actually consists of harmonic. Okay, harmonic can be considered as a voltage or current represent on electrical system at some multiple of the fundamental frequency. It means that in the waveform we have a multiple frequency of current or voltage plus multiple of the fundamental frequency, maybe frequency at the third harmonic, fifth harmonic, and so on. Okay, this is due to the non-linear element in power system. Okay, we have a non-linear load, for example, such as power electronic devices, static power converter, arc discharge devices. Okay, lesser degree rotating machine creates current distortion. Okay, this is the common problem in the non-linear load. Okay, next, okay, voltage irregularities. Okay, we have a voltage unbalance. Okay, voltage unbalance. What is the meaning of voltage unbalance? Okay, voltage unbalance actually is related to three-phase system. In three-phase system, we have a phase A, let's say phase right, phase A, phase B, and phase C. Okay. A voltage variation in three-phase system, which is the three voltage magnitude or the phase angle differences between them are not equal. Commonly in three-phase system, we have a same magnitude for phase A, phase B, and phase C, and we have a different angle between phases actually is equal to 120 degrees. But let's say if we don't have the same magnitude of each phase, or we have a different angle between each phase, which is maybe greater than 120 or less than 120. So that one we call it a voltage unbalance in three-phase system. It caused by large single phase load. It caused by large single phase load induction, large single phase load such as induction furnace, traction load, incorrect distribution of all single phase load by the three phases of the system. Okay, what is the effect? Okay, this one caused by large single phase load. Okay, let's say you have phase A, phase B, and phase C. Maybe in the phase A you have a very large single phase load connected to the phase A, which is not balanced. Okay, what is the effect? What is the effect of the voltage unbalance? Unbalanced system implies the existence of a negative sequence. Okay, consists of negative sequence that is harmful to all three-phase load. Okay, the most affected load are three-phase induction machine. Okay, this is one of the effect of the voltage unbalance. Okay, let's say we see what is the relationship between temperature rise and voltage unbalance. Okay, look at this figure. Okay, we have our percentage of voltage unbalance. Let's say this is 0%. The voltage is balanced. Okay, let's say we have a percentage of unbalance is 1%, 2% until 7%, for example. What is the effect of temperature? Okay, when voltage unbalance actually is increased, we can see from this figure, temperature of the system will be increased. Okay, it will affect to the equipment. Okay, expected temperature will be increased. For example, voltage unbalance is 3%, temperature will be rise up to 18%. Okay, next look at to the transients. Okay, what is the meaning of transients? Okay, look at to this figure. Okay, first look at to this figure. This is a normal voltage. Okay, assume there is no spike here, and then this is the normal voltage. Okay, let's say we have a spike here. This one we call it a transient. Okay, we have a spike here at certain frequency. This one we call it a transient. Okay, what's the meaning of transient? Transient voltage actually is a temporary unwanted voltage. Okay, in electrical circuit that range from a few volts to several thousand volts. Okay, and last microsecond up to few millisecond. Okay, this is the duration. Okay, whether microsecond, it can be up to a few millisecond. Okay, transient actually can be divided into two categories. Number one, we call it impulsive transient, and number two, we call it oscillatory transient. Okay, this is the example of impulsive transient. Okay, impulsive transient. Okay, let's say we have a transient at the point X. Okay, commonly due to the lightning, for example. Okay, so, voltage will be suddenly increase. Okay, for few milliseconds. Okay, for example. Okay, up to let's say how many volt, kilovolt maybe. Okay, number two, we have a oscillatory transient. Okay, it will oscillate. Okay, for few cycle maybe. Okay, this one we call it oscillatory transient. Okay, look at to the impulse transient. Okay, impulse transient. Okay, which is frequently referred to the surge. Okay, surge basically is commonly caused by the lightning strike. Okay, other cause of the impulsive transient actually is electrostatic discharge. Okay, poor grounding, switching of inductive load, switching of power correction capacitor. Okay, power correction capacitor bank, and utility fault clearing. Okay, this is the other causes of the impulsive transient. And impulsive transient can damage a wide variety of equipment that's not rated for such high voltage level. Okay, what is the meaning of this statement? Let's say if we have equipment connected to this supply, voltage supply, let's say our equipment actually is not designed to sustain with the rated of this transient magnitude, of course it will diminish the equipment. Okay, impulses, transient, over voltage are often described as a spike. Okay, we have a spike. Okay, impulsive related to spike or surge. Okay, this is the example of the spike. The voltage is suddenly increased. Okay, impulsive transient are usually characterized by their rise and decay times and peak value. Rise time, decay times, and peak value. This is the example of the shape of the spike or surge. Okay, let's say we have this one. Okay, the voltage or current suddenly increase. Okay, this one we call it a rise time. Okay, let's say suddenly increase from this point to this point, we call it rise time, and then will be decrease. Okay, this decay, this period we call it a decay time. Okay, this is the impulsive transient. This is the category of impulsive transients. We have a nanosecond rise time, let's say 5 nanosecond rise, and the total duration actually is less than 50 nanosecond. This is a microsecond. Okay, rise time is 1 microsecond rise. This is the duration. Okay, and then we have a millisecond. This one microsecond, this one millisecond. Okay, this is the example of the impulsive transient. Okay, this impulsive transient can caused by the lightning. Okay, this is the example illustration. Let's say we have a lightning, for example. This is a voltage. Okay, this is a time. This is a normal voltage. We have a normal voltage. Maybe we have a harmonic. Let's say at this period. Okay, micro breaks here, and then we have maybe we have a switching. Okay, switching of the large load maybe. Okay, of course we have over voltage suddenly increase in the maybe in milli or micro second, and then maybe here we have a lightning. This is the impact of a lightning. Voltage will be suddenly increase. Okay, suddenly increase for certain period. Lightning strike. Okay, and maybe we have indirect, or we have a direct lightning strike. Let's say to the transmission line. Okay, voltage will be increased more than others. Okay, this is the effect of the lightning strike. Okay, this is the example of transient phenomena. Okay, which is less than 1 second. Okay, this duration actually is less than maybe 1 millisecond. Okay, oscillatory transient. Okay, this is the example of oscillatory transient. Look at this figure. Okay, this one oscillate. Okay, the voltage actually is oscillate at certain period. Okay, oscillatory transient actually is a sudden non-power frequency. This is a non-power frequency, maybe higher than nominal frequency. Change in the steady state condition of the voltage and or current waveforms that swing or oscillate. It can be oscillate at positive side. This is a positive side, or at the negative side with respect to the normal voltage waveform. Okay, the frequency of this oscillation can be quite high. Okay, of course can be high than nominal voltage. Okay, this figure shows a typical oscillatory transient, let's say at point Y, occurring on a normal voltage waveform. Okay, this is the IEC and IEEE standards on power quality issue. We have several standards. For example, if you want to look at the power quality issue that related to the voltage sag as well, you can refer to this standard. This standard IEC and IEEE. For example, IEC 61000-4-11, IEC 61000-4-31, or IEEE P1564. That related to the voltage sag as well. If you want to refer to the standard that related to the flickers, this is the standard. Harmonic. Okay, this is the standard that related to the harmonic. PQ test, measurement and monitoring, you can refer to this standard. Okay, I think that's all from this subtopic, from this topic, chapter 7, part 1. And next we will discuss about chapter 7, part 2. Okay, that's all. Thank you. Assalamualaikum warahmatullahi taala wabarakatuh.